Hello, James Flaten here from the Minnesota Space Grant. I'd like to talk for a few minutes about making what I consider nice data plots, and in particular data plots from a PICOLO flight computer. First of all, let me share my screen and show you an example of the way I like to graph data. So a few things to notice about this graph. First of all of the axes are labeled. They have labels with units. Sometimes the font chosen will be smaller than this, and so you can increase the font size if necessary. There's a title. In this case, I put my initials into the title as evidence that I was the one who drew this graph. And then one more thing, notice that this is actually a screen grab from either Excel or Google Sheets put into Google Slides, and then launch, landing, this arrow, burst, this arrow. These are labels, but the labels were not done in Google Sheets. They were done on the slides. So I think a good graph is, well, easy to read, but also has labels, but the labels maybe have to be added to a picture of the graph and not using the same software. So let's take a quick look at some data from a PICOLO flight computer. Here is some raw data from a recent flight, a balloon flight. It's a CSV file, comma separated values file, and I'm going to open it with Google Sheets. So it turns out that this ran for several hours at about once a second. And so there's like 11,000 lines here approximately. In fact, let me find out how many lines are here. Turns out once you have this many lines, things get kind of sluggish. So here are my lines starting at 1. If I go all the way down to the bottom, right. So 11,119 lines, the first of which is a header line. So when you have this much data, sometimes Google Sheets will kind of get slow on you. In fact, I'm struggling to get back to the top. Remember that the first row, this is supposed to describe what's in the various columns. And if you haven't collected data yet, and you notice some things that I'm going to do, it's like, wait a minute, if I only had a column for that, I wouldn't have to go through that data analysis step. So here's an example of something that's missing that I wish was in the set, and you could potentially reprogram your PICOLO this way if you catch it in time. This has a column for time in seconds and time in milliseconds. I really would like a column for time in minutes. I find graphs much easier to read if they're minutes, especially for something that lasts for many minutes or even a few hours. So I'm going to right-click. I'm going to insert a column to the left. I'm going to call this time_minutes. I'm actually using a bigger name here, time t in minutes. Okay. And then time t in minutes will just be calculated as, well, the time in seconds divided by 60. And when I do that, it says, do you want to do it for all of the things? And I say, sure, that's fine. And now I have so many digits. So what I'm going to do next is I'm going to click here. I'm going to format number and tell it, just give me a couple digits. So notice that if this thing updates once a second, 25 seconds, 27 seconds, 28, 29, 30, about once a second, if I keep 2 digits in the minutes column, at least I see a different number in every single location here. So that's good enough. Now let me look around here. I see hours, minutes, seconds. Never plot against that. Time in seconds, time in milliseconds, time in minutes. I'm going to do most of my plotting against that. How fast is the thing running? Apparently running at about 1 hertz. How many satellite? Ooh, no satellites in view. That probably means that the latitude, longitude numbers, which are clearly wrong here, they start to be non-zero, but they're still not right here. In fact, I can tell they're not right because this fix type says I don't have a fix. But if I scroll down a bit, oh, look, within a minute and a half or so, I get a 3D fix, and I think it stays 3D fix for the rest of the time. So one of the things I'm going to do rather early on, let me just do it right now, is get rid of the data that doesn't have a fix. So I clicked, and then I'm doing shift click, so that captures all of those columns, and I right click, and I'm going to say delete rows 2 through 69. Okay, so I'm starting to clean up the data a little bit. Now I only have things that have genuine dates, times, and hopefully genuine latitude, longitude. And then, of course, over here, I have other kinds of information from the GPS. I have information from external and internal thermometers in different units. I have pressure. I particularly like pressure in kilopascals here. I would prefer that this was not labeled PA, kPa. That's just the units. I would prefer that would be labeled pressure PA, pressure kPa, pressure ATM, pressure pounds per square inch. So what's missing from these headers is what is the kind of variable? It has the units, but it doesn't have the variable. You could change that. I have accelerometer numbers, I have rotational numbers, I have magnetometer numbers. Oh, over here I even have hits. It looks like this data tried to have a Geiger counter. I think that may have failed on this flight. Okay, so I did a little tiny bit of cleanup. Let me draw a plot. So, oh, one more thing I'm going to do is I'm going to color this. I'm going to just make it slightly gray as evidence that that wasn't in the original data set. That's not necessary, but it helps me remember what things I added, especially if I add a bunch of calculated columns. Let me plot an example of a graph that's sensor versus time. So sensor versus time means you have a sensor value vertically and time horizontally, and most of my sensors change in time. So this will be a good thing to be able to look at. And so I'm going to grab time from this column, and let me choose pressure. Let me go back to that kilopascal column. So I go over here to kilopascals, there it is. And if I click it, it will forget the time. And if I shift click it, it will grab all the columns between the time and here. But if I control click it, I'm on a PC, it will grab only those two. So now I have time and pressure in kilopascals. And then I'm going to say, I want to make a chart. Insert chart, and it will chart the things that I have selected. And of course, as always, it forgets what kind of a chart I like, and I always like a scatter chart. So that makes sense. Basically, the pressure was steady, and then I started to fly, and the pressure went down, and eventually the pressure started to go back up, and then it got steady again after I landed. Not a very good graph, but let me work on this graph just a little bit. So for instance, let's see what I can do here. If I click on the data points, I can make them smaller. If I click on chart axis and titles, I can give the chart a title. Let me call this pressure versus time with my initials. And I would say that the size of that font there, auto size, I'm not sure what size that is, probably about 24. It was a little less than 24. I can change the size of the font, so I've made it a little bit bigger. Now let me label the horizontal axis. So the horizontal axis is time since boot up in minutes. And that is definitely too small. So let me make that maybe 14 size. Let me make that maybe 16 size. And of course, if it was time since launch, then you would have to shift everything over. Here's something I don't like too much. I don't like the fact that it's got 25.0050.00. Let's see if I can figure out how to fix that. I have figured out that sometimes. I think if I click on this axis, it gives me some options about the axis and the numbers. And if I say source none, get rid of those .00s. And if I say minimum value from, let's say from 0 to, you know what, here's what I'm going to do. I'm going to do grid lines and ticks, 30 minutes. Okay, I like 30 minutes just because people are familiar with 30 minutes. But now it kind of screwed up because it started at 1.55 and I wanted it to start at 0. So I just need to go back to horizontal axis and tell it, give me from 0 to maybe 180. Okay, I like that better, except the font is a little too small. Let me make that font 14 size. There we go. How about this vertical axis? So this was pressure. I can make that font 14 size. I can label it vertical axis, pressure, kilopascals, kPa. Ah, and let me make that size, well, what did we decide, 16? I think this is in pretty good shape. It's got nice grid lines. It's got sizable writing. It's got rather small data points. I think that's in pretty good shape. I'm going to stop with that. This again is an example of what I call a sensor versus time graph. In this case, the sensor chosen is pressure versus time. So when you say sensor versus time, basically you choose two columns. The first column you choose will become the horizontal axis. That's the time. The second column you choose will become the vertical axis. That's the pressure. Um, and I point that out because the next graph I want to draw, I'm going to have a little bit of grief with that because it likes to graph things with the first column horizontally and the second column vertically. And the next thing I want to graph will actually be in the opposite order. I'll see if I can figure out how to fix that. I will call the next graph an altitude versus sensor graph. So pressure versus time, the second word is the horizontal. So altitude versus sensor means I want altitude vertically. The reason I like that is because altitude is vertical after all. So let me make another graph. First of all, let me find some altitude information. Notice that here's an altitude column in feet, here's an altitude column in meters. Both of them are related to the GPS. And then way over here, here's an altitude column in feet and meters, but these are altitudes estimated based on pressure. I want the real altitudes. The real altitudes are the GPS altitudes. So that's this one here. Why would I be interested in altitude versus sensor? It's like, who cares whether it was 10 a.m. or whether it was July 4th or anything like that? Nobody really cares about what time or what date you took the data. People care about where the data was taken, especially where it was off the ground. Maybe where it was in the world, but definitely where it was off the surface. So an altitude versus time graph, an altitude versus sensor graph usually is more instructive than a something versus time graph, even though that's the natural way the data shows up. Something changes and I write it down every once in a while, so I get a record in time. So let me try something like external temperature. So I have altitude in feet from the GPS. I have external temperature. I'm going to control click. I'll take it in Fahrenheit. And I want to plot it. And I want a scatter plot. And it's wrong. The reason it's wrong is because the altitude is on the horizontal axis. And I want the altitude to be on the vertical axis. So there's a variety of ways to fix this. One way is just to take the columns and shift them around so that basically the one that needs to be to the left is to the left, and the one that needs to be to the right is to the right before you draw the graph. On the other hand, if I look right here, it tells me things about what it's graphing. It says the x-axis, and it mentions feet and temperature, and then down here, this happens to be the y-axis, and it mentions feet and temperature. I can just reverse them. So this one is feet, so I'm going to change this one to temperature. And so now it's temperature versus temperature. That's very uninteresting. But then this one is temperature, and I'm going to change that to feet. That's better. Now I have altitude vertically, I have temperature horizontally, and my data points are kind of big, so I'm going to make them smaller. Frankly, I could make them another color if I wanted to, let's make them green, something like that. Okay. There clearly are some data points that are kind of scattered and probably aren't to be paid attention to. But one thing I'm noticing here is that there seems to be definitely a bunch of data points here, which rather differ from the data points here. And I think this is probably because some of the data points are on ascent and others are on descent. And I'm not sure I believe that they should be offset. That might be a function of how I made the measurement. I was moving fast in one case, I was moving slow in one case. I was going from warm to cold in one case, I was going from cold to warm in one case. But it's on a altitude versus sensor data that you most quickly will start to notice things that change with altitude and also possibly change with ascent and descent. If I really wanted to tease out the difference between ascent and descent, I could plot only the ascent data, and I could plot on top of the same graph only the descent data in a different color, and then I would be able to possibly make some more clear statements. But here I'm guessing that this is a discrepancy between ascent, probably here. We ascend slower, so there's more data points here, and descent, fewer data points, but we did descend through the same altitudes, and it looks like it thought it was colder on the way down. And notice also in this case, the temperature definitely decreases as you go up, and then it stops decreasing and stays fairly fixed. That's called the tropopause. The temperature has paused in which way it's going, and then it starts to increase. That's in the stratosphere. And then I come back down into the cold, and I come back down to the ground, and I land. This is not a great graph. It does not have labels. It does not have a bunch of things, but at least you get the idea. Drawing graphs. This one is a better graph. Well labeled. Sensor versus time. This is an incomplete graph, but a very useful one also. Altitude versus sensor. So that's what I have. A little bit about PICOLO data analysis, and also a little bit about drawing graphs, at least the way I think that they should be drawn. If you happen to be drawing graphs of data that was collected on the ground testing data, it might not be quite as exciting. You might not be able to change the pressures very much, but if you go up and down stairs, you could change the pressures. If you have a light sensor, pointed at a bright light or pointed at the sun, you can make those sensors go up and down. So in actuality, this data from a flight shows what happens over the course of several hours, but if your data analysis assignment might be do some ground testing and draw some graphs, they won't look like a flight, but at least you will get the sense of whether or not the data is varying. On the other hand, it will be weird because the pressure will go up and it will go down, and it will go up and it will go down. It's like, what's going on? I can't understand that as a user. That's where the labels come in. It's like, here's where we walked down the stairs. And here's where we got on the elevator and went back up again. That's why the pressure went up and then it went down and then went up again. Because the labels tell me what it was you were doing while you collected the data.